here to actually speed. Let's go in here to our drive and ground speed. Now, what we're going to do is set and configure these up. We see vehicle speed here is set for our digital one. We're going to go and just shut this to the off. Let's go here and just do this off and click OK. Now, let's go to our drive speed. Drive speed is coming from our digital input number 1. So we're going to change this to our DI number 1, digital input 1. And it's going to be a Hall effect sensor. It's going to be a rising edge trigger. And then the pull up here, we will turn that on because it's a Hall effect sensor. We need to have that on. The filter, I'm going to set this relatively high at something like 50. Now the scaler here, this is going to account for scaling this to read the correct speed reading when we're actually driving. Now this is going to depend on the number of teeth that are mounted on the actual pickup wheel. In this case, it's using the factor ABS pickups. And it's going to also factor in what the tire size is going to be. Now this is running a 24.5 by 9 by 13 tire. So we can go and crunch this number, or crunch these numbers into our Excel spreadsheet calculator to figure out a scalar value to give us a good starting point. Now you still need to go do a driving calibration where you're not going in and accelerating, you're just cruising at a, let's say 30, 40 mile per hour. And you're going to make sure that the speed readings between driven and undriven speed are matched within 1 mile per hour so that when we're referencing anything for the traction control in terms of the slip, they're going to be reading properly. We can actually start to take care of this real quick. Let's just put a scalar value in here. Go to the wheel speed. The number of teeth in this case are 50. I've counted on this car. The wheel diameter, this is going to be in centimeters. Now, the wheel diameter in this case, this would be the total tire diameter. In this case, it's going to be a 24.5. So the wheel diameter in centimeters would be 62.23. So the total scalar that we need to enter in here is going to be, in this case, 2,555. So let's go and enter that in. That's going to allow it to scale properly for the front tire size and the number of teeth. So as that pulse is coming in from the front wheel speed sensor, it's going to be able to translate the pulses to a speed reading properly. So that's going to give us a starting point. Doesn't mean it's going to be perfect. The threshold mode, there's going to be, you see a table here. We can keep this at 2 volt. That should work for the threshold. So we're going to go here and let's try to click off this guy here. I might need to go in and let's go to escape. I had to hit the escape button to get out of there. Okay, so that looks good for our drive speed. So the ground speed is going to be now on our digital 2. So input source, we're going to set this to digital 2. Click OK. It is going to be a Hall effect sensor again. It's going to be a falling edge trigger. It's going to be a Hall effect, so we need the pull up on. The filter, we'll set it at a filter of 50. The scalar, we need to go and account for this. So it's 50 teeth on the back for the pickup, for the actual pickup wheel and the wheel speed sensor. And it's going to be, in this case, a 3.6 inch tire, 24 inches, and it's a 15-inch rim. So we need to go and put that number of 24 in. Let's go ahead and just go to our calculator. So it's 50 teeth. In this case, the diameter of the tire, the whole wheel, is going to be 24. This would be 60.96. So we're going to type in here 60.96, enter. And now the scalar value should be 2,608. That's what we need to enter in there to get us close to counting the pulses and translating that into a speed reading. So we're going to go enter that in, 2,608. And again, we're going to probably end up changing this, but 2,608. Let's give us a good starting point. We can set this to a table value. We can leave those values again at 2 as default. That should work in terms of the detection. Those values are really primarily used for a switching type function with a digital input, or if you're using a VR type of sensor. In this case, we're not using VR. We're running the Hall effect sensors, which are more reliable, better signal than the VR ABS sensors that are found on the factory ABS on the car. So the last thing we need to go and account for is going to be our gear shift force. So we need to go in here to Motorsports and look up a gear shift force, or double click on this. The input source here is going to be under digital input. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.